Hello everyone, my name is Aryan Naik and this is my project 3. So I've learned a lot about a variety of manufacturing tools and processes, and I would like to present 5 of my favorite topics when it comes to manufacturing. So I'm going to talk about rotary swaging, roll forging, electropolishing, centralist grinding, and thermal spray. Let's get started. So what is rotary swaging? Swaging is a metal forming process used to reduce or shape the diameter of rods, tubes, or wires by applying radial compressive forces. It involves a repeated hammering or deformation of the material, often at a high speed, to achieve the desired shape without removing such material. Swaging is commonly used to taper, size, or shape parts in various industries like aerospace, automotive, medical, and even jewelry. In rotary swaging, the diameter of the rotor tube is reduced through the radial reciprocating motion of 2 or 4 dies. This motion is driven by a set of rollers housed within a cage, where a cam-ended hammer intermittently engages a roller to close these dies. The internal diameter and wall thickness of the tube can be adjusted either with or without the use of mandrels. Some important applications are in aerospace, where fuel lines, hydraulic tubes, engine parts, and structural components are very affected, as well as automotive industry, which includes drive shafts, steering columns, axles, shock absorber tubes, and exhaust system components as well. And of course, the firearms manufacturing, specifically rifling and gun barrels and cartridge cases. So why is this important? Well, it's important because it's highly efficient for high volume production, minimal tooling costs, easy handling of various materials, making it flexible, enhanced material strength because of cold working conditions at room temperature, and precision and consistency. However, the main reason is the ability to adjust wall thickness and diameter through mandrels, which is very important for medical and fluid systems specifically. The uses and capabilities and limitations can be talked about as well. The uses include diameter reduction and tapered shaping, but swaging also allows for custom cross-sectional profiles that expand on the variety of shapes and sizes production can come in, as well as fatigue resistance. Some limitations include it can't effectively or efficiently execute very complex shapes whose intricate nature gets in the way of a good swage. Also, the repeated hammering makes the tools wear down quite often and it needs maintenance. Finally, the part diameters are limited to around 50 millimeters, which is not very good. So let's talk about roll forging. Roll forging is a metalworking process in which metal billets or rods are passed through specially shaped or rotating rolls to achieve a desired shape, thickness, or contour. Unlike traditional forging, which uses hammering or pressing as mentioned before, roll forging involves shaping metal by squeezing it between two rotating rolls that progressively deform the material. This process is commonly used for parts that need to be elongated or reshaped along the length of with improved mechanical properties. So some of the main applications are also in aerospace and automotive, but agriculture is an important one as well. It's used to create various parts for tractors, harvester, and plows, as the process it provides the strength and wear resistance necessary for equipment that operates in these harsh conditions. When it comes to toolkit manufacturing, roll forging is also very, very helpful, and it's used to produce hand tools, wrenches, and other components that require durability and strength. And we buy these tools all the time at common stores like Home Depot. So why is it important to me? It's important because it offers a reliable way to enhance the mechanical properties of metal parts, such as strength, toughness, and fatigue resistance. The process produces minimal waste, which makes it cost effective, especially when working with expensive materials. Additionally, roll forging improves the grain structure of the metal, creating parts that are less prone to failure under stress. This quality is crucial in applications where component failure can be catastrophic, such as in the automotive, aerospace, and railway industries. So, what are some capabilities and limitations? Well, one important capability is material efficiency, where because the roll forging shapes the metal without removing any material, there's very little waste, making it cost effective and environmentally friendly. There's, of course, fast production and high volume production, which is important as well as uniform cross sections that are consistent throughout the part, as shown in this picture. Some limitations include simple shapes. It can't do complex shapes very easily. Surface defects after the roll, and it requires skilled operator training because they need to maintain dimensional accuracy and product consistency, which normal training couldn't do. So let's talk about electropolishing. This is an electrochemical process that smooths and polishes the surface of a metal by selectively removing microscopic amounts of material. The removal occurs at a controlled rate, targeting the high points on the surface and resulting in a more uniform, smooth finish. It's commonly used on metals like stainless steel, aluminum, copper, titanium, and is often preferred in applications where cleanliness, corrosion resistance, and precise surface finishes are critical. So, what are some applications? Other than aerospace, the food industry is very, very important because you need to create tanks, piping, containers that they have to have no contamination, and the surfaces need to be easy to clean because of hygiene standards set by government agencies. Electronics are also important because it reduces particle contamination and ensures a cleaner production environment for sensitive electronics that everyone buys. So why is this important? Well, it's crucial for industries, as mentioned before, that require smooth, clean, and corrosion-resistant surfaces. By removing these imperfections in the surface and reducing friction, the polishing enhances performance, lifespan, and reliability of metal parts. This is important because a lot of industries require high hygiene and high standards, and this is contributes very well to that. So, what are some capabilities and limitations? One capability is corrosion resistance, but because it increases the metals, it makes it suitable for environments that are exposed to moisture, chemicals, or extreme conditions. Biocompatibility is also important for medical devices, and deburring is very, very important as well because it removes microburrs, sharp edges, rough spots that may be left over from manufacturing processes, which is very important. Limitations include the conductive material requirement. Insulation cannot be used, and they must only be used with metals or other conductive materials. There are environmental issues because of waste, and thickness reduction is another factor as well. Let's move on to centerless grinding. This is a machining process that uses two rotating wheels to hold and rotate a workpiece, while abrasive particles on the grinding wheel remove material. Unlike other cylindrical grinding methods, centerless grinding does not use a spindle or a chuck to hold a workpiece in place. Instead, the workpiece is supported between the grinding wheel, which performs the cutting, and a regulating control wheel, which controls the rotation and feeding speed of the part. So, what are some applications other than automotive and aerospace? As we mentioned before, the medical is very important. It's used to produce hypodermic needles, surgical instruments, and other medical devices with tight tolerances, which is very important. Consumer electronics is also affected, as mentioned in previous processes. So, why is it important to me? Well, it's important because it enables high volume production. It's very important for that. Um, Cylindrical components with a high degree of consistency and accuracy are needed, and this improves that. It's more efficient than other grinding methods, and it can produce with uniform diameter, smooth surface finish, and excellent roundness, which contributes to precise production. So some capabilities and limitations. Well, one capability is no work holding. Since there's no need for a chuck or a center, centerless grinding allows for easier setup and faster loading and unloading, reducing handling time. Also, a variety of materials can be used in this process. So for limitations, only cylindrical shapes can be used, and parts with irregular shapes or non-cylindrical features, it limits the applicability of these parts. Workpiece size variety is also limited for the workpiece specifically, and defects can also arise quite frequently. Let's talk about thermal spraying. Thermal spraying is a coating process in which melted or heated materials are applied to a surface to form a coating. The materials, which are typically metals, alloys, ceramics, or polymers, they're fed into a thermal spray gun, which are then melted by an energy source like a flame and then propelled towards a substrate. Upon hitting the substrate, the molten material cools rapidly and forms a protective coating. This process is widely used in industries to improve the wear resistance, corrosion resistance, thermal production, and other surface properties. What are some applications? Well, an important one is the oil and gas industry. The process is used to coat equipment exposed to harsh conditions, such as offshore oil rigs, pipelines, and drilling equipment, to protect against corrosion, erosion, and wear. Industrial equipment is also important because of parts like gears, molds, and bearings. So, why is it important to me? Well, it's important to me because it allows manufacturers to apply coatings that significantly enhance the durability, as mentioned before. These coatings, they offer a wide range of properties such as thermal resistance, wear resistance, corrosion protection, electrical conductivity because metals are used as well. These are also very important to me because I use a lot of metallic devices. So let's talk about capabilities and limitations. So one important capability is TBC, or thermal barrier coatings. These are commonly used in the aerospace and automotive industries, and they protect components from extreme heat, such as re-entry into Earth's atmosphere. Another capability is surface protection and repair and restoration, which are very easy to do with if you thermal spray. So some limitations include initial setup costs, which are very expensive, as well as sprayable forms. Um, by sprayable forms, we mean that The materials that are melted, they need to be sprayable, so it cannot come in the form of a powder or something that cannot be sprayed. And also the substrate material. The success of the thermal spraying depends on the material properties of both the coating and the substrate. Some substrates, especially those that are fragile or heat sensitive, they may not be suitable for thermal spraying. Here are some of my resources, and this was just created for educational purposes. Thank you so much.